Hey guys, what's going on? So this time around I have a nice two-parter for you. In the first part of this video series, we're going to be talking about server-side rendering as well as create React app. Now in the second part of the application, we're actually going to apply server-side rendering to the Material UI application that we've built so far. So let's begin by first talking what server-side rendering actually is. Now to understand what server-side rendering or SSR is, we first need to talk about two basic approaches to building websites and web applications. Now the first one is known as client-side rendering, or for short CSR, and you might have also heard the term single page application, and it's kind of related to the same category. Now the other one is server-side rendering, of course, and this one is also abbreviated as SSR. Okay, so let's talk about first the client-side rendered applications. And these have been popular mostly in recent years because of the rise of client-side application frameworks like React, Angular, Vue, Ember. So client-side rendered applications, also known as single-page applications most of the time, they work by rendering every single page on the client as opposed to on the server. Now the process goes as follows. So first of all, the server will serve up a single static HTML document to the client. Then the browser will pick up the HTML document. It'll basically start parsing it, and as it encounters link elements or script elements or images or other references, it is going to load all those different assets. So CSS assets, JavaScript, images, fonts, and so on. Now, once the JavaScript bundle is loaded, it's typically going to fetch data from an external API web service, and it's going to construct the DOM or the document object model. Now, in single-page applications, the user basically navigates between routes via the history API as opposed to page reloads as in traditional applications that are rendered on the server side. To improve the performance of the website, the application itself will also typically lazy load remaining JavaScript chunks on demand. And this is also known as code splitting. So imagine an application that has a user dashboard behind a login page. So if the user only visits the website and never goes to the login page, there's actually no reason to load the code for the user dashboard because the user is never going to log into that dashboard. So only when the user actually logs into the application, only then does it make sense to load the JavaScript code for that user dashboard. So this is what code splitting is all about. Now, to further improve the performance of the application, the static side of the single page application can actually be served up from a CDN to obviously speed up the load time. So what happens is a single application is essentially a static site. All you have is HTML, you have your JavaScript bundle, and perhaps some CSS and image assets. And now all of these static assets, of course, can be cached on a service known as a CDN. And by doing that, you're going to improve the load time of your application. Now, of course, there are pros and cons to this approach. Let's first talk about the benefits of this approach. Now, the first one I listed is actually decreased load on the server. Because if you remove all of your business application logic and move it to the client side, that's actually going to take off the load from the server. So you're going to have less load on the CPU as well as the RAM and memory on the server itself. This, of course, also improves the UI and UX interactivity. Now, what I mean by that is that the single-page applications often have a feel of native apps on mobile devices. And this is often due to smooth transitions and very fast responsiveness of the website if it's built as a single-page application, as opposed to a traditional multi-page app that is server-side rendered. Now, the other advantage I listed is actually static hosting and caching. Now, what I mean by that is that a single-page application doesn't necessarily need to have a server behind it. And of course, if you do need a web service that provides the data for your app, then you do need to have a separate application that runs that backend service. But for the frontend itself, you could actually serve it from a CDN just as a static conglomerate of files, including HTML, CSS, and JavaScript. So for the frontend itself, you don't necessarily need a separate server to host it on. You could actually just serve it from a CDN, which is often cheaper and also faster solution to implement. And the last point I kind of alluded to is decoupled architecture. What I mean by that is that the backend of your application that actually serves the data and also handles things like authentication and file upload and all that stuff, it's actually decoupled from your frontend. So your frontend exists as a separate static application that simply makes calls to that API service. So in that sense, this is easier for development as well as scaling. Now, of course, to every pro, there's also a con. So if we want to talk about disadvantages, the first one is probably the most obvious one. It's that the single page application actually has a very slow initial render. And you've probably noticed that some of the websites actually take up a lot of time to load initially. And that often happens because the website has to request a heavy JavaScript bundle on the very first load. Now the size of that bundle is often heavy because of the framework that it holds. So this could be a React or Angular framework, and as well as the application code itself. So even though the subsequent page requests are going to be faster, because it's a single page application, the very first initial render is often going to take up a lot of time. And this could be anywhere from a couple of seconds to perhaps 10 or even 15 seconds, depending on the capabilities of your device. So if it's a mobile device, it's obviously going to take a lot more time, and also depending on the network capabilities. Now, the other point I mentioned is heavy JavaScript dependency. And what I mean by that is that the client absolutely has to enable JavaScript in the browser. And of course, because the app depends on JavaScript so heavily, if JavaScript fails to load for whatever reason, then the app will fail to load itself. Now, I actually linked this to a very comical article here on the internet, and it kind of explains the different steps that the browser has to go through by actually downloading JavaScript. And only after all those steps succeed, so if the network connection was stable, if the file was actually delivered successfully, only then will the application finally boot, and only then will you actually see something on the screen. So this not only takes time, but this is also kind of risky because there's so many different things that can go wrong during the process. Now, the other point I mentioned is that single page applications are traditionally not very SEO friendly, and that's because the server will send off an empty HTML file. It'll not contain any HTML markup until JavaScript actually takes over and builds the DOM or document object model. And the same kind of goes for accessibility. So if accessibility is an important feature of your application, then perhaps you should prefer a server-rendered app over a single-page app. Now, like I said, there's a few caveats that have to do with single-page applications. And the first one is that the initial render of a single-page app depends on JavaScript bundle. And because of that, it can be very slow. Now, there are quite a few factors that play into this. The first one, like I said, is the bundle size. And like I said, it'll hold the framework itself as well as the application code and all of the dependencies that that code depends on. And the second factor, of course, would be network latency. So if the internet network is not stable, then that's, of course, going to affect the download time of the bundle. And lastly, the hardware limitations, of course, play in, because the slower the device is, and especially this has to do with mobile devices, then the longer it'll take to process JavaScript and build the actual app. And the other caveat is that the page is actually technically ready to render once it serves up the HTML and CSS assets. So once the HTML page or HTML document has been loaded, and once the CSS OM or CSS object model has been established, then after that, the browser is technically ready to render what it has to display. Now, in single-page applications, of course, this is not taken advantage of, and that's because the file that the browser receives essentially has nothing in it. It's just an empty body with a single div, perhaps, as it is a case with React. So the actual markup gets constructed by JavaScript. Now, if we could somehow get that basic markup from the server, and if we could get the styles along with that markup, then we could technically render the app very quickly and then take up the extra time to load JavaScript in the background. And then once it does load, then we can add the JavaScript interactivity to the already rendered web page. Now, like I said, the browser does not necessarily need to wait on JavaScript to load or execute, so we can actually paint before JavaScript even loads. And unfortunately, this is not taken advantage of with traditional single-page applications, but we're going to get back to that point very soon. Now let's talk about server-side rendered apps. So with server-side rendered apps, also known as multi-page applications, every single page is rendered on the server as opposed to the client. So what basically happens in the process is that the server will serve up a new HTML document on every single request. So even though in a single page app we get a single HTML document once, typically once unless you refresh the page manually, with a multi-page application, every time you switch from a page to page, you will get a brand new document from the server. Then the second step is that the browser will load and parse the CSS assets to paint the UI. So this kind of goes back to the caveats that we've listed over here. So in this case, the browser actually starts to paint once it gets the CSS. It doesn't necessarily have to wait on JavaScript to load. And then the browser is going to load and parse deferred JavaScript to enhance the UI. Now, what I mean by deferred JavaScript is that JavaScript can actually be made non-render blocking. And this is often done by either placing a script tag for JavaScript and the end of body to only load blocking JavaScript after all other assets. Now, actually, this I have to explain further. So what happens is that there are some assets that can be loaded asynchronously. So things like images, those can be loaded in parallel. When it comes to CSS assets, well, we first have to load them in order to display the page. So oftentimes you won't be able to see the page until you actually load and process all the CSS assets. So that's why CSS processing refers to as render blocking. The same actually goes for JavaScript. So if you start loading a JavaScript file, the loading of that file as well as processing of that file will block the display of the entire document. So that's why you often see script tags being placed at the end of bodies. So this way the browser will process the entire HTML document. It'll display the CSS assets, which are often placed in the head section of the document. And then it will start loading the script tag once it gets to the end of the file. Now, this is not really perfect because the processing of the HTML document can't really be completed until it gets to the end of file. And of course, it's being blocked by the JavaScript file that's being loaded and processed. So a better solution with modern browsers, including IE11 by the way, would be to actually put a defer attribute on the script. So what this is going to do is it's going to tell the browser to actually continue parsing HTML while actually loading JavaScript in the background. So this is the preferred approach to handling this issue. Now, like I said, the browser will load up and parse deferred JavaScript, and this will be used to only enhance the UI. So in the case of a multi-page application, typically the JavaScript is only used to improve the user interface and user interactivity. This is not done to boot the entire application because most of the business logic is still handled on the server. So this is the case for multi-page applications, or at least the more traditional multi-page applications. Now, if the user wants to navigate between routes, this is done by requesting a brand new page from the server, like I said. So this is less efficient as opposed to single page apps, because if you have a single page app, well, if you switch to a new route, all that's going to happen typically is the app is going to request perhaps some new data from the API to populate the page and then only update a single section of the HTML document. It's not going to refresh the entire page and load everything brand new. Now, what's often happening in the browsers by default is that the browsers like Chrome will often also cache the assets like CSS, JavaScript, and images for faster page load. And in fact, if you open the network tab, you're often going to see that some of the assets are actually being loaded from the disk as opposed to loading them from the server. And this is actually, in fact, the case for client-side rendered app as well. And the last thing I'll mention is that the server can also cache static HTML and as well as CSS and JavaScript assets too on a CDN to decrease the load on the server. So the thing is that if you're hosting a static site on, let's say, a node server, it only makes sense to save the markup of the HTML and perhaps also other assets like CSS and JavaScript on a CDN, so that when the clients begin to request the web page from that server, it doesn't necessarily need to regenerate that same page and those same assets every single time. It can actually cache them on a CDN and serve them, so it can save up some resources on the server. Now let's talk about some of the pros of server-side rendering. The benefits are, first of all, of course, a fast, first, meaningful paint. Now what I mean by that is when a user actually sees something on the screen. So this is when an HTML document as well as the CSS assets have been finally loaded and processed. And this can happen, like I said, before any JavaScript even is loaded. Now, the second point is that the server-side rendered apps often have better perceived performance. So as it turns out, the server-side app can actually take up longer to load. And this is especially the case when the initial load has already happened. And let's say you're switching between different pages. In a single page app, this will happen pretty instantaneously. But in a server-side rendered app, of course, this is going to take more time because every single page will be loaded brand new. Now for the user, the initial load will actually still be faster, and that's because the browser will paint the DOM after it got the HTML and CSS assets. It doesn't need to wait on JavaScript to load or parse it in order to actually display something meaningful to the user. And it's going to seem to them as if the app is actually working quicker. And the other point is, of course, that multi-page apps are more SEO friendly as well. Now let's talk about the disadvantages of server-side apps. Now the first disadvantage, of course, is the increased load on the server. And that's because every single time you request a page, the server will have to generate a new markup for that request. The other disadvantage is that server-side rendered apps often have latency. And again, that also has to do with multiple back and forth page requests and page reloads. And the last point is that oftentimes multi-page applications have low UI or UX interactivity, and they typically don't have that native app feel. And again, this oftentimes has to do with page reloads. So to bring this battle between CSR and SSR to a close, let's actually look at a case in point of Walmart. So what I have over here is an article on medium.com, actually from Walmart Labs. And they do provide us with a nice illustration over here. So let's begin by looking at server-side rendering. And this is presented in this article as a more preferable approach. So what happens is that the server will first send off HTML and CSS assets. The browser will start loading them, and once it's done processing them, it's actually going to paint the UI. So even though the JavaScript files are still being loaded in the background, and the application is technically still not fully loaded, the user can already see something meaningful on the screen. So this is what the first meaningful render refers to. Now, like I said, even though we already have something to see on the screen, the JavaScript assets are still being loaded, and once they do, the React application will take over, and then the web page finally will become interactable in the last step. And by that I mean that the user will finally be able to actually interact with the user interface instead of just seeing the preloaded state of the app. And now let's look at client-side rendering. And this approach, like I said, is presented here as less advantageous. So once again, the server sends off HTML, CSS, and JavaScript assets to the browser. The browser will have to wait on loading the JavaScript, and that's because the JavaScript is going to bootstrap the entire application. So there's nothing to actually show to the user because the HTML file is pretty much empty. There's nothing in it until the JavaScript constructs the DOM. And then once it does, React will actually take over, and finally the application is going to become viewable and interactable. So once again, we're able to get a viewable app in the second step, which is why it kind of seems to work faster for the end user. But in the case of single page applications, we only get a viewable and interactable app only in the last step. And that's why for the end user, the single page application will seem a little bit slower than a server-side rendered app. Now back in our presentation over here, it'll be nice to actually be able to get the best of both worlds. So what if we could somehow combine the pros of server-side as well as client-side rendering? And in fact, it is indeed possible. It is possible with React because React library is actually isomorphic. What I mean by that is that React can run not only in the browser, but also on the server, in a native app, and even in a VR headset. What we can do for a web application is we can actually pre-render that application server-side for a fast first paint in the browser. And once the browser loads the bundle, we can actually let React take over and make our application a single page app. Now let's take a look at this approach a little bit closer. So what's happening over here is that we have a server rendered React single page application. So it's kind of a mix of both. So first of all, the server is going to pre-render the app into an HTML string, and it's going to serve up that string along with CSS and JavaScript assets. Now then, the browser will take over. It's going to load and parse CSS to make the page viewable. So this step actually happens before any JavaScript is even loaded, so we don't have to wait on it. We can actually make the page viewable right away. And this often happens faster because JavaScript typically takes longer to process and load. Then after that, the browser will then load the JavaScript bundle, and it's going to boot the entire React single page application to finally make it interactable. And then the final point I'll mention is that React doesn't necessarily need to re-render if the server and client markup are identical. So what if we wanted to go with that approach? What if we wanted to combine both SSR and CSR? Let's talk about Create React App. Imagine we already have a single page application in Create React App. Can we make it server-side rendered? Now before we get into that, let's actually first define what Create React App is what are its advantages, and what it's actually designed for. Now, Create a React App, often for short CRA, is a zero configuration incubator for single-page React applications by Facebook. So right off the bat, you see that Create a React App is actually designed for single-page apps, as opposed to something like multi-page applications that are server-side rendered. Now, CRA allows you to set up a dev environment with a bundler, transpiler, linter, test runner, as well as a live server. So I know these terms can be a little bit daunting, so let's actually go through all of them before we get into more details. So a bundler, to remind you, is basically a tool that bundles up assets, and these include JavaScript assets, oftentimes the modules, as well as the dependencies that your app requires. So this could be React, React DOM, and all the other dependencies. And then the other assets could be CSS, images, fonts, etc. So read this again. A bundle actually bundles up different kinds of files. So not only JavaScript files, but also CSS, images, and even fonts. Next up, a transpiler. What it does is it basically transforms ES6, or we could say ES Next, because this also includes ES7 and ES8. So it transpiles all of the ES Next features down to ES5 for better cross-browser support. And that's because older browsers like IE11 don't really have much support for ES6 features. Now, a linter is a tool that basically analyzes the source code for statistical and logical errors. And this often includes formatting, spacing, semicolons, single quotes versus double quotes, and things like that. So there's actually different kinds of linters that follow different guides and directions. But what's common between them is that they actually enforce a common system and very consistent system for your project. And this is useful for teams that work on multiple projects because different people will have different styling preferences. So instead of having multiple people code in their own fashion, the project can enforce a shared style guide so that everybody's going to follow it and the application will be consistent across iterations. Finally, a test runner. It's probably something you already know, but I'll just mention it. It's a tool that allows for unit testing and code coverage reports. Lastly, live server, pretty self-explanatory. It's basically a dev server that watches files and recompiles and auto reloads as those files change. Now moving on, let's talk about the philosophy of Create a React App. And this is taken straight up from readme.md file on the official GitHub repo. So the first one is a one build dependency. So it doesn't actually have dev dependencies of Webpack, Babel, or ESLint in package JSON. Instead, it abstracts away all of those external dependencies in a separate repo, which is React script. The other one is zero configuration. Like I said, Create React App comes with sensible defaults, and it's also optimized for production builds. So you don't necessarily need to configure it manually. And then lastly, no locking, meaning that you're still able to customize the setup if you want to, and this is done through ejecting the app. Now, Create React App is not really a silver bullet. There are very specific use cases that it's designed for. Now, the first one, of course, is for learning React. So for someone who is like a beginner and wants to experiment with React in a simple application or a toy app, basically. And this is also cool for learning tooling. So how Webpack can be set up, how you can set up a project with Babel, and so on. Now, the other use case would be single page applications or static sites. And this is something we talked about before. Lastly, like I said, React is really good for rapid prototyping. It's also good for demo applications or just simply side projects of your own. Now, there are quite a few caveats that I want to discuss as well. Create React App comes with ES6 support. Now, this includes stage 2, 3, and 4 features. So things like async await, dynamic import, class fields, as well as JSX and Flow support. But Create React App doesn't have support for stage 1 or 0 features, so you can use something like do expressions or function bind feature. And sadly, Create React App doesn't even support decorators, which is a stage 2 feature actually. Now, the other caveat you have to be aware of is that even though Create React App does have polyfills, it only has a few. So the few ones that it does have are promise, fetch, and object assign. Now, there are quite a few other methods that you're probably going to encounter. So things like array find, array includes, even things like string includes or string starts at, or even things like symbol or the INTL API in the browser. Now, those ones you're going to have to install manually because Create App doesn't actually come with them. So you're going to need to install and cherry pick them either from core.js, or you can just install Babel polyfill. So this is just a manual step. Again, not necessarily a disadvantage of Create React App, but it's definitely something you're probably going to need to do if you are working on a larger project. Now, as far as linting, Create React App does come with ESLint, but it actually does need a plugin for the editor. And if you do want to enable auto formatting in the editor, you're also going to need to install Prettier. As far as testing, Jest is a really good test runner. It comes with JS DOM in Create React App, and it allows you to create test cases as well as assertions. And that means you have one library for both of those. You don't need two libraries like it is the case with, let's say, Mocha and Chai. But the thing is that Create React App in and of itself doesn't really allow you to isolate components when testing them, because those components are going to be rendered along with the children. And for use cases when you want to isolate the unit tests of individual components, you're probably going to need to install Enzyme, but you could also install React testing library with JS DOM. So again, a manual step, just something to be aware of. When it comes to optimizations, Create React App is actually really good at this. So it's going to minify, uglify, and compress your code for a production build. But then Create React App is also going to include hashes for caching, and it'll also include source maps for debugging. Now, if you do want to analyze the bundle size and actually explore which dependencies take up how much space, you're going to need to probably install something like Source Map Explorer if you want to take a closer look. Now, there's quite a few things that are out of scope of Create React App, so it's things like CI/CD, as well as deployment, UI UX libraries. So let's say if you want to install Bootstrap or Material UI. These things are really out of scope of Create React App, but they're actually very well documented in the official guide on GitHub. Now, finally, after all of that, let's actually talk about the downsides of Create React App. So as it turns out, we can't really use Create React App for server-side rendering. And that's because Create React App will actually produce static bundles. It has no awareness of a server whatsoever, but I do have to mention that Create React App actually supports pre-rendering. There's actually a very nice library for doing that. The library I'm referring to is known as React Snapshot, and what this one does is it pretty much crawls your application for different routes. It takes up those routes and generates static HTML files. And when you deploy your app, it's actually going to serve up those static files. So it's kind of in the middle between pure server-side rendering and pure single-page application. Now, the other disadvantage, like I said, you can only build single-page applications, but not really multi-page apps. The other actual disadvantage is that you can't really pass environment variables to a Create React app. And that's because those variables are defined during the build time. Because the HTML and CSS and JavaScript bundle is pretty much static, so there's really no way to pass dynamic variables into it. If you do want to do that, again, you're going to need to set up a server, like a Node.js server. You're going to need to load the HTML into the memory, and you're going to need to manually populate the variable placeholders in the HTML template. Now, the other disadvantage is probably more sound. It's the fact that Create React App is kind of opinionated, and some people might even say that it's actually bloated. That's because it does contain a lot of libraries and tools that you might not necessarily need for your application. So even though you set up this beautiful and nice app, it abstracts away all the config, all the setup away from you, you don't really know what's happening behind the scenes, and you don't really know if you necessarily need all of those NPM dependencies installed for your app. Now, even though it is optimized for most use cases, if you do need to configure something more advanced, or if you do need to tweak the configuration for your app, you're going to need to eject. There's really no way to go around this. And worse, the ejection command is pretty much permanent unless you use Git to save up the state of your app. And lastly, even though Create React App is really easy for developers to get started, it actually does have a steep learning curve if you are indeed interested in ejecting it and discovering what's actually happening behind the scenes. But again, like I said, the documentation is pretty elaborate, so you could find pretty much anything as far as configuration. So what is the alternative to Create React App? Well, the alternative is actually a custom project setup. So what we're going to do in the very next video after this one is we're going to take a look at the exercise database application that we've been working with in the Material UI playlist. What we're going to do is we're going to take that application and actually convert it to a server-side rendered app. So we're going to need to install all the dependencies ourselves, and we're going to need to set up the project manually. Now, it might seem difficult at first, but we're going to go step by step, and as you're going to see, it's perfectly doable and it's not that complicated. So for the time being, I'm signing off. I'm going to see you in the next video. Take care.